Good evening, sir.
Good evening, beta. So today I am going to discuss questions related to the topics I have discussed with you up to this point. So, question number one, in YDSC experiment capital D. So, how we are going to solve this question? So here, this is a capital D, that is 50 centimeter. 50 centimeter. Small d is 0.1 centimeter. 0.1 centimeter. A thin mica sheet of refractive index n equal to 1.5 is introduced in the path of one of the beams. If the central fringe gets shifted by 0.2, what is the thickness in micrometer? Micrometer of the mica sheet. You have to find out the thickness. ठीक है ना? You have to find out the thickness. So here this should be 0.2 centimeter. So make it correct. If the central fringe gets shifted by 0.2 centimeters. So what they are saying here, in YDSC experiment, you are having two slits like this. This is symmetrical line. This is source S1, S2. Okay. So if you place a mica sheet in front of one of the slit, this, then the central fringe which was placed here, central fringe was here without the mica sheet. When there is no mica sheet, this is the position of the central fringe, 0th fringe. This was 0th. But when you introduce this will shift here. This will be shifted here, here. And how much this distance is? This distance is 0.2 centimeter. So due to the introduction of this mica sheet in front of one of the slit S1, the central fringe will shift, ठीक है ना, in the upward direction. In the upward direction by a distance 0.2 centimeter. This distance, capital D, this is the separation between the screen and the slit plane. Small d is the separation between two slits here, between S1 and S2. This separation, this is small d. So can you tell me what will be this shift if this shift is x naught? If this shift is x naught, what will be this shift? In the last class, I have given you a formula. Bolo beta, this will be capital D by D. And this will be mu minus 1 into T. T is the thickness. Thickness of the mica sheet. This is the thickness of the mica sheet beta. Now substitute all these values. What is x naught? X naught is 0.2. So what is x naught? X naught is 0.2 centimeter. Capital D, this is 50 centimeter. Small d, that is 0.1 centimeter. And mu minus 1, mu is how much? Refractive index is 1.5. So mu is 1.5 minus 1. And this will be t beta. This will be t. So this will be how much? This is 0.5. 1.5 minus 1.5. So 1 by 2. So this will be 0.2. So this will be 2 into 10 to the power minus 2 divided by, this will be 50 here. This will be 50 here. So this will be how much? This will be the thickness T. So thickness T, that will be 0.4 into 10 to the power minus 3. Or this will be 4 into 10 to the power minus 4 centimeter. ठीक है, and this will be equal to 4 micrometer. So our answer will be 4. Option B. Option B is the correct answer here. So option B is the correct answer. Is it clear to everyone?
Yes, sir.
Yes, sir.
Good. Next question, beta.
सर और नोट हो जाए
Yes, beta?
सर नोट कर लेंगे
Okay, beta. Please note it down.
Excuse me, sir.
Yes, beta, please.
So 1.5 minus 1 will give, so
0.5.
0.5 over there.
0.5 is
And
1 by 2.
yes,
0.5 is 1 by 2. So this will be 0.2. 0.2 into 0.2. This will be where?
4, right, over there.
This
4
will be
into 10 power
4.
minus 2. Yeah.
This will be 4, na, here.
Yeah.
This should be 4. You are correct. This will be 4. So this should be 0.8, na? You are correct. So this will be 0.4. So this should be 0.8, beta. So this should be 0.8. So this will be 8 into, you are correct. So correct it, beta. So this will be 8 micrometer. So this is 8 micrometer, beta. So look at this. Answer will be 8 micrometer. So this is the first question. Please make it correct here. This is 1 by 2. 1 by 2. So I was talking 0.2 into 0.2, but I have wrongly written 2 into 10 to the power minus 4. But this is 4. 4 into 10 to the power minus 2. So answer will be this one. I can make it correct. Here, your answer will be 8 beta. This will be 8 micrometer. This will be the answer. Please note it down quickly and correct it and go to the next question, question number 2. Now go to question number 2. The seventh bright in YDSC using a light of wavelength 550 nanometer. So lambda is how much? Lambda is 550 nanometer. This is nanometer. Shift to central maxima after covering the two slits with two sheets of different refractive indices N1 and N2. Okay, so what they are saying that seventh bright fringe in the YDSC experiment is shifted to the position of the central maxima. ठीक है ना? Central maxima. So this seventh bright fringe is shifted to the position of the central maxima after covering the two slits with two sheets of different refractive indices N1 and N2, but having same thickness 6 micrometer. The value of N1 minus N2 is, you have to find out the value of N1 minus N2. So here, this is the source here. This is symmetrical line. Here, these are two slits, S1 and S2, S1 and S2. And what you do here, you place one of the mica sheet here, okay? You place one of the sheets here. Its refractive index is, you say N1. Another sheet is placed here. That is N2. And screen is here, and what happens? Okay, this is the position. This was the position of the central maxima earlier without the introduction of these sheets. But what happened here? There was a seventh maxima. There was a seventh maxima, 7th-order maxima. It shifted to this position. The central maxima shifted to this position. So how much distance it is shifted? Or even you can say if this N1 is greater, it depends upon this is shifted here. Can anyone tell me when this 7 is going to shift in the downward direction? It will shift in the downward direction if this N2 is greater. But here, because they are saying me that find N1 minus N2, so automatically I am assuming N1 is greater. So I should say like this, I should do it reverse. I should say that seventh maxima here. There was a seventh maxima here. And I'm saying this seventh maxima is shifted to the position of central maxima. Why? Because they are saying me to calculate N1 minus N2. So I'm assuming that N1 is greater than N2. Okay? I'm just assuming this. And if N1 is greater, though automatically this N1 is going to introduce more part difference. Okay, na? This N1 plate, it is going to introduce more part difference, extra part difference. So pattern will shift in the upward direction. This was the position of the 0th fringe earlier, and this was the position of the 7th. So it is shifted from here to here. And this 0th fringe, it will shift in the upward direction. So try to understand. Automatically, it will be shifted here. So how much shift is this? What is this distance? Can anyone tell me how much this distance will be? I write it as 7 beta. Separation between the central maxima and the 7th maxima, this will be 7 beta. So this separation is going to be 7 beta. So they are shifted. Central fringe is shifted by the 7 beta. So what it will be? What will be the shift here? Shift will be x naught. Shift will be x naught when, and this will be capital D by D. And what will the formula when in front of both the slits you have introduced a plate? That will be n1 minus 1. Thickness is suppose T minus n2 minus 1 into T. This is the extra path that is introduced by this. This is the extra path that is introduced by the second plate. So this will be, now this is 7 beta. So I can write here 7 beta. What will be beta? Beta will be d lambda. So d lambda upon small d. And this will be d by d. And this will be, here this will be n1. This term, it is going to cancel out, and this will be n1 minus n2 into t. And this capital D will cancel out, this small d will cancel out. Okay, and what will be the n1 minus n2? N1 minus n2, that will be equal to 7 lambda upon t. Now this is 7 into, okay, lambda is 550 nanometer. 550 nanometer. And what is the thickness? Thickness is 6 micrometer. So this is 6 micrometer. So 6 into 10 to the power minus 6. This is micrometer. This is nanometer. So this will be 10 to the power minus 9. Calculate this and find out. Find out beta kitna hoga ye? What will the
Sir?
value of n1 minus n2? Yes, beta?
I have a doubt, like why we did not add up those extra parts, like though
Because
doesn't.
they are introduced in the last class. I have discussed. ठीक है, actually you are interested in finding part difference. ठीक है ना? Try to understand. Suppose you are talking I should draw with different color. Suppose light is passing through it and reaching at this point, and light passing through it is reaching at this point. This is O point. This is S1. This is S2. So what will be the part difference? Part difference will be delta. Delta will be how much? Delta will be, बोलो बेटा कितना होगा ये? बोलो. This will be
S1O minus
S1O.
S2O.
हाँ, you can say S2O. ठीक है ना? Earlier without the glass plate, this was S2O. But due to this plate, some extra path is introduced. So that will be plus. This will be N minus 1. S2, sorry, N2 minus 1 into T. This will be, ठीक है, minus, this will be S1O. ठीक है, this has traveled in air S1O plus extra path that is introduced by this, plus this will be N1 minus 1 into T. N1. So this will be S2O minus S1O. This is, and here this will be plus N2 minus 1 into T minus, this will be minus N1 minus 1 into T. This will be, ठीक है, and this will be delta. So if delta is 7 lambda here, you are saying the 7th maxima is here. So what will be the delta here? Delta will be 7 lambda. So delta will be 7 lambda here. So you are going to write 7 lambda here. And S2O minus S1O, this will be how much you have find out. Okay, we have calculated it with the help of geometry. I have find out its value. Okay, so from here you can find out the value of x. So in this way, this difference is coming into the picture. So one glass plate is introducing extra path in this ray in this wave S1 to O, and second glass plate is introducing extra path, ठीक है ना, extra path for S2O, the wave traveling from S2 to O. So because this part difference, extra part difference is introduced in the path of these two different waves, that's why this difference is here. Is it okay?
Yes, sir.
So what will be the answer? Anyone calculated? This will be
0.64.
0.64. 64. This was the next question, beta. Please note it down. And then I will go to the next.
Sir,
Yes, beta, please.
can you please teach that sum again?
Yes, beta, please.
Can you please teach this sum again?
This one.
Yes, sir.
Actually, what you are doing, you are introducing one of the glass plate in front of S1. Second glass plate is introduced in front of S2. So by introducing these glass plates, you are introducing extra path difference. Extra. So one of the extra path is traveled by this wave that is traveling from S1 to O. Okay. So that extra path is here, N1 minus 1 into T. And this seat is introducing extra path, ठीक है ना, for the wave that is traveling from S2 to O. So this is here. This is N2 minus 1 into T. So because one extra path is traveled by this, another extra path is traveled by this, and you want to find out path difference. So automatically there will be a difference between this extra path and this extra path. Okay, because these two places, they are introducing extra paths, but for two different ways. One is introducing for this, another is introducing for this. And here on the screen, you are interested in path difference. So that's why here extra path was N1 minus 1 into T. For this was N2 minus 1 into T. So you have to take the difference of these two. Okay, you have to take the difference of these two. Okay.
Yes.
Even you can go through the last lecture. Okay, in that last lecture, I have discussed this thing in detail. Please go through that. This is question number 3. Question number 3. In a Young's double slit experiment, the slits are at a distance 2L from each other. So small d is how much? Small d is 2L. Small d is 2L from each other. And the screen is at a distance capital D from the slits. Okay. So this is capital D is okay. We also assume it as capital D. If a glass slab of refractive index mu and thickness T is placed in the path of one of the beams, the minimum value of D for the central fringe to be dark. What they want that at the center, there should be a dark fringe. Whenever this glass plate is introduced, what was happening without the glass plate at the center, you are having central bright fringe. But as you will introduce this glass plate, you are getting a dark. You are getting a minima or you are getting a dark fringe there. So you have to find out this minimum value of D for the central fringe to be dark. Okay? You want a small value of this D here. So how much extra path is introduced by this glass plate? That will be mu minus 1 into D. Okay, this. So here I'm drawing only the screen here. This is the screen. And this is the central position. So here at point O, you are going to get the 0th minima. You are going to get you are going to get a bright fringe here. But when you introduce a glass plate here or mica sheet, whatever it is here, what do you happen? You are getting dark. So try to understand, this will be a maxima, this will be a maxima, this will be a maxima. Here you are going to have this type of maxima. But in between these maximas, there will be a minima. So try to understand, in between maximas, there will be a minimum here. So when you are introducing a glass plate, what can happen? This is first minima. If this first minima shifted here, if first minima is shifted here, then automatically there will be a, so this is first minima. This is first minima. And this was the 0th maxima, central maxima. So if first minima replaces the central maxima, then you are going to have a dark fringe at the center. Okay? So this will be x naught. Even I can tell you directly, but I'm writing the same formula, d by d, and this will be mu minus 1 into t. Okay, this will be. Now, how much shift is this? This central, this first minima and central one, their separation between them is equal to beta by 2. This is beta by 2. So I will solve you within a minute also. Directly even you can solve. So this x naught, it will be beta naught, beta by 2. So you can write 1 by 2 beta. Beta is d lambda by small d. Okay. Here they are saying in place of this d, this is small d. They are saying this is small d is actually equal to 2L. What they are saying is small d is equal to 2L. So I'm writing 2L here, 2L here. And they are saying thickness is d. Thickness is d. So they are saying this is 2L. In the question it is given. This is 2L. And this is d. This is d. And this will be equal to d by 2L. Sorry. Mu minus 1 into d. So d will cancel out. 2L will cancel out. And this is small d. Small d will be lambda upon 2 mu minus 1. Mu minus 1. This will be your answer. So option D will be the correct answer. In another way, you can think, if you are saying first minimize positioning here, due to the introduction of this slit, you are saying this first minima is now positioned here at the center. So what is the part difference at the center if first minima is there? That will be lambda by 2. Earlier, without this, here at this point, part difference was 0. But when you introduce glass plate, this introduces an extra path due to which now here you are getting first minima. What is the condition for first minima? Part difference for the first minima is lambda by 2. So directly you can say this glass plate is introducing a part difference of lambda by 2 like this. So how much part difference this glass plate is introducing? This is mu minus 1 d equal to lambda by 2, and you can directly write this d equal to lambda by 2 mu minus 1. You just have to understand. Okay. So earlier without the glass plate at point O, what was the part difference? 0. You was getting central maxima, 0th maxima. But when you introduce glass plate, now part difference at the center is corresponding to first minima. First minima part difference is lambda by 2. So mu minus 1t that is introduced by the glass plate is actually lambda by 2. Is actually lambda by 2 is this. Okay. Is it clear?
Yes,
Hello.
sir.
Yes, sir.
Next question. All these questions are asked in various exams, and you will find out I have covered most of the questions which are asked in your exam. Okay. So this is next question. The distance between the successive intensity maxima, the distance between the successive intensity maxima seen on the screen in YDSC is found to be S. So what is S? What is S, beta? What is talking?
Beta.
This is beta, beta. So what is beta? Beta is S. Beta is S. Suppose now the experiment is repeated with the spacing between the two slits being doubled and the whole apparatus is being immersed in the water. Earlier it was in air. The fringe spacing will be take the refractive index of the water to be 4/3 is. You have to find out nu beta prime. So try to understand in air. What is beta? Beta is S, and this was equal to capital D lambda upon small d. In air, this was the situation. I'm saying the separation between two slits is D. Capital D is the separation between the slit plane and the screen, and lambda is the wavelength. Now what they are doing, they are immersing. Okay? They are immersing this apparatus in water. Okay? And they have doubled spacing between two slits is being doubled. So you have to find out nu beta. So what will be nu beta? You can say it as beta 1 in air, in water. In water, what will be beta 1? This is beta 1. Capital D is same. This small d, this is doubled, so this will be 2D. And lambda, what will be lambda in the water? Lambda W, this will be lambda upon refractive index. Refractive index is how much? 4/3. This will be 4/3. So this will be 3/8 d lambda upon small d. Okay, 3/8 d lambda. What is this d lambda? This is S. So I can write this should be 3/8 into S. This should be nu beta 1. Okay, when you are immersing this apparatus in the water and you are observing what is beta, nu beta, then this will be 3/8 S. This will be the answer here. Option D. Option D is the correct answer. So here, option D is the correct answer. Beta. Please note it down quickly. Can I go to next? Question number 5. A collimated white light source illuminates the slits of YDSC and forms the interference pattern on the screen. If one slit is covered with a blue filter, which one of the following statement is correct? So what blue filter is going to do? Basically, blue filter means it will allow to pass only blue color light. The light that is of blue color, other lights will be blocked. So filter means it is going to allow only a particular wavelength, and that wavelength is corresponding to blue light. So through this slit, only blue light will pass. So you have to find out which one is correct. So what they are going to do here? So white light, this is a white light source here. This is a source of white light. You are having a YDSC experiment like this. So from this slit, you can say this is S2. This is white light that is emerging. So from here, white light is emerging. And from S1, what you have done S1, in front of S1, you have placed a slit or filter. This is a filter actually. And what this filter is doing, this filter is only allowing blue light. So through this only blue light is passing. This is blue light. So what will happen? And this is white light. So no interference pattern is observed after the slit is covered with the blue filter. Wrong. Interference pattern remains unchanged with and without the blue filter. That is also wrong, because you are allowing only one wavelength. Here you are allowing all the Vibgyor pattern through this. ठीक है, so that will not be an answer. A blue interference pattern is obtained. The central maxima is blue with the colored higher order maximum. Can you tell me what is the condition for coherent sources or coherent light to form the interference pattern? बोलो बेटा. To form the interference pattern, ठीक है ना, two sources should be coherent. You should have coherent sources. So what you should have? You should have same frequency, same frequency, same wavelength, same wavelength, and constant power difference. Power difference should be constant. This will be. So look at this condition. So they should have same frequency. So here, this blue light is going to interfere with the blue light that is present in the white color. So what is going to happen here? Interference will occur in between the blue light, ठीक है ना, that is coming out through the filter, and the blue light, ठीक है ना, blue light component of this white light. So blue light component of this white light is going to interfere with this blue light, and you are going to get interference pattern where maximas will be of blue color. So where maximas will be of blue color, so your answer will be C. So your answer here will be C. So option C will be the correct answer, beta. So option C will be the correct answer.
सर आपने रीजन क्या बताया एक बार?
Beta, for interference, for interference, what is the condition? Main condition is two sources, they should be coherent. And for the stationary pattern, these two sources, they should be coherent, and for the coherent sources, frequency should be more or less equal, wavelength should be equal, and power difference should be constant. So power difference is constant, that is okay, and frequency that should be equal. So here there is a frequency of this blue light, ठीक है ना? So this blue light is going to interfere with the other coherent light that will have same frequency. So here in the white light, all the colors are there. If you look at this white light, it is made up of VIBGYOR. ठीक है? So this is made up of VIBGYOR, VIBGYOR. So this blue color light is going to interfere with this blue color, and you will get the interference pattern that is blue in color, means its maximas, it will be of blue color. So maximas will be of blue color, beta. Is it clear?
सर
Yes, beta.
सर तो केवल मैक्सिमा ही तो दिखेगा,
हाँ,
क्योंकि सर केवल
तो that's
क्योंकि
why
सर
they are
केवल
saying ना, a blue interference pattern is obtained.
यस सर.
ठीक है ना? That's why C is the answer.
ओके सर.
Next question, beta. Question number 6. Go through this question. Consider the interference of two coherent electromagnetic waves whose electric field vectors are given by this and this. ठीक है? Where phi is the phase difference. The total intensity is, you have to find out the total intensity, beta. बोलिए. You have to find out the total intensity. What will be the total intensity? So, what you are going to do here, ठीक है, what will be, they are perpendicular polarizations. If you look at this, they are having perpendicular polarizations. E1 and E2, they are having perpendicular polarizations, बेटा. ठीक है, उनका polarization कैसा है? That is perpendicular. So if they are having perpendicular polarizations, ठीक है, so what will be the intensity due to this, and what will be the intensity due to this? So they are actually, they are going to form the pattern, they are going to have some resultant intensity, but maximas and minimas you are not going to get here. Here you are not going to get maxima. Overlapping will take place, superposition will take place. ठीक है, some intensity will be there, uniform average intensity will be there, but maxima and minimas will not be there. So total intensity, that's why they are saying the total intensity is. So if two waves, they are not coherent, means you are saying that I incoherent, in any way you can find out in a incoherent, that will be equal to I1 plus I2. I1 plus I2. ठीक है, what will be I1 here? I1 for this will be amplitude square. Its amplitude is E naught. So this will be amplitude square. ठीक है, and what will be the intensity of this? That will be E naught square. But what they are saying intensity is given by 1 by 2 epsilon naught E square average value. So what will the intensity I1 due to the first one? That will be 1 by 2 epsilon naught. And you can write here, this is E naught square, amplitude square. This is a constant here, E naught square. Plus intensity due to second, that will be simply 1 by 2 epsilon naught. And this will be E naught square. This is the simplest way. You can take it out. So this will be epsilon naught. ठीक है ना? E naught square. It will be epsilon naught E naught square. So this will be. So we know that intensity will be amplitude square. But they are writing here 1 by 2 epsilon naught E square. So I'm just writing 1 by 2 epsilon naught E square plus 1 by 2 epsilon naught E naught square. And it will be epsilon naught E naught square. This will be your answer. Here, this will be your answer. Is it clear?
Yeah.
Sir,
Hello? Yes, beta, boliye please.
sir, for the maxima direction should be same.
For the maxima.
Yes, sir.
I am unable to understand your question. For the maxima, direction should be same. Okay, for the
Yes, sir.
interference. This is
Yes, sir.
polarization, beta. ठीक है? State of polarization should be same to get interference pattern. What he is
Okay,
saying?
sir.
So I can write here to
Yes,
get
sir.
stationary, to get stationary interference pattern, pattern, state of polarization, state of polarization should be same, should be same for both, same for both coherent sources. ठीक है, in this case, ठीक है, superposition is taking place. I'm not saying that superposition is not taking place. Superposition will take place, but interference pattern, you are not going to get interference pattern. ठीक है, so here superposition, however here you can say here superposition will take place. However, superposition will take place. Position will take place. And some intensity, some resultant intensity will be there. Some resultant intensity will be present. ठीक है ना, it will be present. So this was question number 6. Now go
Sir,
to the next. Yes, beta, please.
in the question, it is given that the interference of two coherent electromagnetic wave, but you find out the intensity of incoherent source. Why?
Why? Because he's saying that interference is taking place here. From interference, it means they are superposing, they are overlapping. ठीक है ना? They are superposing or they are overlapping. But due to this overlapping or this superposition, ठीक है ना? You are not going to get here the maximas and minimas. So that's why I'm saying that they are not forming interference pattern, so they are behaving like incoherent sources. ठीक है? They are behaving like a incoherent sources. Coherent, their frequencies are same, but due to their different polarization, you are not going to get that. ठीक है ना? Maximum intensity and minimum intensity, that type of intensity distribution will not be there, but an average intensity will be there. So that average intensity you are going to get in case of incoherent sources. That's why I have written here incoherent, intensity of incoherent sources. ठीक है? Is it
Okay,
clear
sir.
what I am saying?
Okay, sir.
So here, due to the individual sources, try to understand due to this, because they are not interfering. So at any point, due to this E1, there will be intensity. Plus, at that point, due to this, there will be intensity. If you want to say, I can remove this because this formula was for incoherent. Also, you can write here resultant intensity. You can write IR also, but that this formula is same as we have used for incoherent sources. Okay, you can also write it as IR. You can also write it as resultant intensity. So here actually that type of redistribution of intensity is not there. Maxima is not formed, minima is not formed, and reason is their state of polarization is not same. Their state of polarization is not same. I can show you in a simple manner other than this. If you are having, I'm making it more simpler. Suppose this is E1. Suppose E1 is, I say this is I cap. I cap A e to the power iota omega t. ठीक है? This is E2, E2. This will be J cap. J cap A e to the power iota omega t plus phi. ठीक है? This will be, so what will be the resultant electric field at a point? This will be I cap A or e to the power iota omega t plus j cap. This will be, you can say A, or even you want this, you can write this A1, you can write this as A2. This is your choice. A2 e to the power iota omega t plus phi. I just want to show you the same phenomena but in a more simpler manner. ठीक है? So now what will be E star? E star. Even you can take here this e to the power iota omega phi common. Iota omega t common. So what will be left with us? This will be I cap A1 plus J cap A2 e to the power iota phi. You are going to get this. Now, what will be E star? E star will be, this will be e to the power minus iota omega t. And here this will be I cap. This will be A1 plus J cap. This will be A2. If you want to place here star, that is okay. Okay, this will be e to the power minus iota phi. It will be. So what will be the intensity? I, we say that this will be E star dot product with E. So when you are taking the dot product, this exponential will cancel out by this exponential, and it will be I cap A1 plus J cap A2 e to the power iota phi, and it will be dot product here. This will be I cap, or you can say star here and minus here. This will be I cap A1 plus J cap A2 e to the power iota phi. This is a dot product, so I cap with I cap. ठीक है? I cap with I cap, so this will be A1 square plus this will be A2 star, this is A2. So this will be A2 square. So here, what is this? This is I1, intensity due to the first source, and this is the intensity due to the second source. So you can say it as resultant intensity. You can say this is resultant intensity here if you want. ठीक है ना? This will be the intensity. So I have used this formulation there. ठीक है? I have used this aspect there. Is it okay now?
Yes, sir.
So that's why I was writing incoherent. Otherwise, there is no need to say them coherent or incoherent. ठीक है? Just use this and you are going to find out the answer. Next. Question number 7. So here, this is a very good question. In YDSC experiment, the light incident on the slit is monochromatic and plane polarized, with the direction of polarization being parallel to the slit. So I'm making two slits here. This time I'm showing you slit from the front side. This is one of the slit that I'm observing. ठीक है ना? This is S1. This board is slit plane. What I'm saying, I'm observing slit plane from the front. This is slit plane. And this is second slit. This is second slit. ठीक है? Now, is monochromatic and plane polarized with the direction of polarization being parallel to the slit. So try to understand when light is emerging from here, that is like this. This is electric field vector. This is S1 and you can say this is E1. This is E1. ठीक है? So what is E1? I'm saying this direction is Y, or you can say this direction is Y cap. ठीक है? And I'm saying this is the direction that is X cap. This is X cap direction. So how can you write this electric vector? This is E1 vector. ठीक है? It is oscillating in the Y cap direction. So I'm writing Y cap here. This is the direction of the electric vector. Suppose its amplitude is, you can say this is A1. ठीक है? You can write it as A1. अरे भाई. ठीक है? Or A, whatever you want. You can write it as A. E to the power iota omega t. This is. ठीक है? So what is in, I'm interested here, what is E1? ठीक है? This is E1. Second, if one of the slit is covered with a thin plane polarizer, so in front of this, try to understand, they have placed a polarizer here. Hopefully all of you are aware about the basic aspect of the polarizer. Polarizer polarizes the light, or polarizer, you can say, allowed the light in with electric vector in a particular direction. That particular direction is called as path axis or EG axis. So whenever you are having a polarizer, that polarizer allows only those electric vectors which are parallel to the path axis or EG axis, is being parallel to the slit. If one of the slit is covered by a thin plane polarizer with the EG axis at 45 degree to the slit, so this is EG axis, you can say this is the EG axis at 45 degree. So I'm saying this is the EG axis of the polarizer. EG axis. EG axis here. 45 degree to the slit, the value of the ratio I max and I min. So here you can say, from here I can write that amplitude A1 is equal to A. A1 कितना है? A1 is equal to A. Can you tell me if very simple question which you have studied in your class 12 also? ठीक है, in polarization. So if a plane polarized light, ठीक है, plane polarized light like this, or unpolarized light, whatever light is this, ठीक है ना, if it is this is plane polarized light and you are saying that it's electric vector. Okay, in another way, in a more simpler way, I explain you. ठीक है, try to understand. I use different color. I can explain you in a different way. Just try to understand. You are having a electric vector here. So on this polarizer, this electric vector is going to hit. ठीक है, this hit. This angle of pass axis is 45 degree. So the component of this E1, ठीक है, component of this that is going to pass through this. So component of this will pass through this pass axis. What will be the component? If this is E1 or E2, whatever you want to assume, this is E2 vector. What it will be? What this component will be? This will be E2 cos 45 degree. Cos 45 degree. So what will be E2? E2 will be this direction. I will write direction here, but this will be cos 45. So this will be A upon root 2. ठीक है ना? I'm writing here. Just try to understand this. This is a little bit tricky question. This will be A cos 45. You can write. So this will be A, and this cos 45 is here. This component will pass. ठीक है ना? A cos 45 e to the power iota omega t will be there. ठीक है ना? Along this direction. What is this direction? Can anyone tell me what will be this direction at 45 degree?
X cap plus y cap.
By root 2.
Yes, sir.
ठीक है, unit vector is correct, but good. So this will be the eta cap direction. So what will be eta cap direction? That will be x cap plus y cap. And for unit vector, this will be root 2 here. So here I'm going to write x cap plus y cap divided by root 2. This will be the profile. ठीक है ना? This is going to be the profile. तो ये profile होगा बेटा. Is it clear up to this point? So here this electric vector is, now you write like this. This is E1. E1 is just y cap A. ठीक है? Y cap A and e to the power iota omega t. And E2, that will be, first is x cap, second is y cap. First I am right. Cos 45 1 by root 2. ठीक है, 1 by root 2 is here. Root 2. This will be 2. So this will be, first I am writing a by 2. First I am writing y component y cap. E to the power iota omega t. Another component will be there. That will be a by 2. A by 2, but its direction will be x cap. ठीक है, its direction will be x cap. A by 2 and e to the power iota omega t. So this is the electric field profile that is coming from slit 1 and slit 2. First, try to understand this. Is this clear to you? So what I am saying here, this electric field was incident like this. ठीक है? Electric field was incident like this. So this was the electric field, electric vector, you can say, that is incident, E2. But we have placed a polarizer that is allowing only the component of the electric field which is parallel to the path axis. This angle is 45. So component of this electric vector in this direction will be E2 cos 45. 45. So I write it. This is E2 cos 45 I have introduced here. ठीक है, introduced here. This is cos 45, A cos 45, e to the power iota omega t. That will be okay. But direction of this allowed electric vector that is coming is eta cap, n cap, and n cap is this. This is the n cap direction. So I write this electric vector in this way. Now I split it into two component y cap and this is x cap. Now in which component, in between which component interference is going to take place so that intensity is going to maxima or having minima? Can you tell me
Sir,
which
Y
component?
direction.
Y cap
Y
direction. Try
direction.
to understand.
Yes,
Correct,
sir.
beta. So interference will take place in between these two components. ठीक है? Due to this component, due to these components, try to understand what will be I max. I max. What will be I min? First, I want to write the maximum intensity and minimum intensity. ठीक है, due to these interfering component, this its amplitude is A, its amplitude is A by 2. So A1 is A, A2 is A by 2. So it will be A plus A by 2, A1 plus A2 whole square. I minimum, it will be A minus A by 2 whole square. This will be. But what is going to happen due to this? This is not interfering. So what will be due to this component of the electric vector or light? Due to this electric vector, there will be a uniform intensity everywhere. Here, because they are interfering, they are going to create a interference pattern where redistribution of intensity is there. At some places, you are going to get maxima, you are going to get minima. I have written there the intensity, maximum intensity and minimum intensity. What this component is going to do, because it is not interfering, it will create a uniform illumination. What will be the intensity due to this at every point? That will be square of its amplitude. ठीक है, if you forget this and you are having only this light, what will be the intensity of this light? That will be amplitude square. So A by 2 square. So what will be the intensity at the position of maxima? That will be plus A by 2 square. This intensity will be present everywhere because that component of electric field is not interfering. So that is providing uniform intensity. That X cap component, that is creating a intensity just amplitude square. So that will be A2 square. A by 2 square. That will be A by 2 square. So you have to add this and you are having. So due to interference, you are getting this maximum intensity and this minimum intensity. But that left out component X cap, ठीक है ना? That X cap, that is also creating intensity. That is not due to any interference. Simple source is there and its intensity will be same everywhere. And how much intensity will be? That will be amplitude square. Amplitude is A by 2. So this will be A by 2 square. Is it clear? So how much it comes out to be? देखना बेटा. Please check it how much it is going to be. बोलो बेटा. I max कितना होगा? Can anyone tell me please? This will be 3 by 2. 3A by 2. So this will be 9 plus 1. This will be 10 by 4. A square. So this will be 5 by 2. 5 by 2 A square. And how much it will be here? This will be A by 2 square. A by 2 square. Okay. So this will be A square by 4 plus A square by 4. So this will be A square by 2. ठीक है ना? So these are the maximum intensities and minimum intensities.
सर
Yes, beta, please.
ये वो दोनों फॉर्म कैसा है एक बार वापस बता देंगे प्लीज, ये आई मैक्स आई मिन वाला.
देखो, try to understand this component and this component. They are interfering. They are having same polarization, same frequency. So this is A1. What is the amplitude here? That is A. This is A1. This is A2. So due to interference, what will be the maximum intensity? A1 plus A2 whole square. So this will be A plus A by 2 whole square. What will be minimum intensity? That will be A minus A by 2 whole square. A minus A by 2 whole square. That will be. So first I have written the intensity that is going to come into the picture due to the interference. So at some point due to the interference, you are having maximum intensity. At some points, you are having minimum intensity. What are those maximum and minimum intensities? This and this. Now, there is one more source. That source is you are having this electric field also. X cap A by 2 e to the power iota omega t. What will be the intensity due to this? This will be simply amplitude square. So intensity due to this will be A by 2 square. So this will be the intensity everywhere. Here there is no redistribution of intensity. Here this intensity will be present at every point.
Yes, sir. Okay, sir.
So here I have added this, here I have added this, and you are getting this. This is the maximum intensity, this is the minimum intensity. So I max minus I min divided by I max plus I min. That will be pi by 2 a square minus a square by 2 divided by 5 by 2 a square plus 1 by 2 a square. So here this will be 4. 5 minus 1 is 4. Here 5 plus 1, that is 6. So it should be 2 by 3. Okay? So it should be 2 by 3. So answer will be 2 by 3 here. Beta. So this will be the answer here. Answer will be option B. Option B will be the answer. So 2 by 3 will be the answer of this question. Okay, this was another question. Can I go to the next question?
Yes, sir.
The intensity of primary maxima in a two slit interference pattern. ठीक है ना? There is a two slit interference pattern is given by I2. ठीक है? So I2 is the intensity of the principal maxima or primary maxima due to double slit. How much it will be? That will be A. If they are same identical slits are there, then this will be 4A square. This will be 4A square. ठीक है, is given by I2. And the intensity of the primary maximum in a three slit interference pattern is given by I3. So that will be how much? I3. This will be A plus A plus A whole square. So that will be 9A square. 9A square for the same slit parameters and the intensity of the incident light in both the cases I2 and I3 are related as. So divide this I2 by I3. I2 by I3. So this will be 4 upon 9. So I2 will be equal to 4 upon 9 I3. ठीक है, 4 upon 9 I3. So option D is the correct answer. So here option D is the correct answer button. This was another question. ठीक है, next. Consider two coherent point sources S1 and S2 separated by a small distance. Yes, beta.
Last slide, please.
Okay, beta.
So could you please show the previous one as well?
Okay, beta.
Thank you, sir.
Welcome. Beta. Now, go through this. Consider two coherent sources, S1 and S2, separated by a small distance along a vertical line, and two screens P1 and P2, as shown in the figure. Which one of the choices represents the shapes of the interference fringes at the central regions on the screen? Circular on P1 and straight line on P2. Okay, this is S1, this is S2. And here, this is slit plane. So what is this? This is slit plane here. So I can write, this is slit plane I am showing here. So this is slit plane. So if a screen is here, try to understand if you are having a screen here, what type of fringes you are going to get. You will get hyperboloid, ठीक है ना, hyperboloid or revolution or hyperbolic slits on this screen you are going to get, and they will appear straight line to you because you are observing the very small part of those fringes. So here you are going to have straight line fringes. Straight line fringes, but remember this, that these straight line fringes actually are the parts of hyperbolas. Straight line fringes you are going to get here, and perpendicular to this on this side, ठीक है ना, if you place the screen on this side, then you are going to get circular fringes here. Here you are going to have concentric circular fringes. So here they are concentric circular fringes you are going to get. Fringes. You are going to get. Now, there is one question that you have to try. That's a very good question. And I have written this question, but actually I should discuss this question after when I have completed thin film interview. This is not related to thin film, but here same method we uses. So you can try this question. ठीक है? You can take a snapshot of this and you can try this question. In the next class, first I am going to discuss thin film interference, and after discussing thin film interference, then I will explain you this question. Okay, but you can try here. What you have to do, I can tell you one thing, that you have to find out the part difference. This light is coming directly here at the receiver, and another light, this is lake, okay, water lake. So here one part of the light is reflected from the lake water and reaching at the receiver antenna here. This antenna is receiving, ठीक है ना, two different parts here. This was a single wavefront. It is divided into two parts. One part of the wavefront here, one part of the wavefront is directly reaching to the receiver. Another part of the wavefront is reaching here after reflection. After reflection, it is reaching here. So you have to find out the part difference in between these two. When they are reaching here, then apply the condition of interference, first interference maxima. Okay, and try to solve the answers, this question. One thing you have to remember, whenever light is reflected back from a denser medium, an extra phase of pi or an extra path of lambda by 2 is introduced. So when light is reflecting from here from the water surface, an extra phase of pi or extra path difference lambda by 2 is introduced. So take care of that thing. And this is a very, very good question. So that's why I'm saying to please try to solve this question. But this is a very difficult question. This is a difficult question. If you're not able to solve, doesn't matter. Okay? I will discuss in the next class. So for today, I am stopping here. In the next class, I will discuss thin film interference, anti-reflection films, and questions related to that. Okay, beta.
So
Thank you very
question 9,
much.
please.
Okay, beta.
Sir, please do full slate.
Yes, beta, please.
Sir, all slates.
Okay, please. This is the first one. is the first one. Second. Third. Fourth. Fifth. Sixth. Seven. Eighth. Nine. 10. 11. 12. So it's up to this point. ठीक है, try to solve this one बेटा.
Thank you, sir.
Welcome बेटा. Good night बेटा.